Hello everybody, I will start my today's another coding practice. So in this video, I will solve a question, longest palindromic subsequence. So in this question, I'm given string s and finds the longest palindromic subsequences ranks in s. So that means that I will think of every possible palindromic subsequence and return the maximum length of them. Okay, and now that being said, um, here there's the definition of subsequence. So subsequence is a sequence that can be derived from another sequence by deleting some one or no element without changing the order of the remaining element. So for example, if I think of the string ABC, A is a subsequence, AB is a subsequence, and AC is also because I can skip B, but CA or BA isn't because I can't change the order of characters. Okay, so that being said, let me introduce the solution of this question. The first approach I can use is the top-down dynamic programming. And the second approach I can use is the bottom-up dynamic programming. Okay, so let me start with the top-down dynamic programming approach. Okay, so I will explain with an example, BBBAB. And when I take a look at this string, my task is to find the longest subsequence, which is palindrome here. And when I took a look at leftmost character and rightmost character, they're the same. Both of them are B. And in that case, I should definitely use these B's in the palindrome subsequence. There's no reason that I skip this. Yeah, either of them. So I will choose this B and B. Okay, so I will choose this B and B. And the remaining task I have to answer is, what's the longest palindromic subsequence length in this inner string BBA? And once I find it, I should return 2 plus that length. Yeah. And when I try to solve this question, the inner string question, the similar thing can be said. When I take a look at this substring, the leftmost character is B and rightmost is A. But in this case, they're not the same. So it isn't possible that I choose and use both of them. I have to skip at least one of them. So I will think of the case when I skip the, leftmost character. And also I will think of the case when I skip the rightmost character. There are two cases for this. And also, let me just clarify that here, right here, this means that A is always be chosen. It is possible that I skip also A, and both of B and A are not included in the longest palindrome subsequence. Yeah. But yeah, it's up to my future's decision. Yeah. Anyway, after, yeah. So firstly, I will try to find the longest palindrome subsequence in BA, which should be 1, because 2 characters are not the same. And when I take a look at the line 11, the other case, the longest palindrome subsequence is now length 2, because BB is the same. Then I can say, comparing 1 and 2, 2 is longer. So the maximum subsequence length, maximum longest palindromic subsequence length is 2. And in the end, I will return 2 plus 2 is 4. Yeah, for this given string. So let me, think what I've done so far. Abstractly saying, And essentially it's saying, what I did is, I will try to find the maximum length of the palindrome subsequence in the given range. And for that, I will take a look at leftmost character and rightmost character and compare them. That's the condition 1, that they have to be the same. And also the second condition is that, oh, sorry, they don't have the same. According to, I mean, depending on if leftmost and rightmost characters are the same or not, the logic differs. Just that. And what I want to say is, okay, so if I try to guess the maximum length in the given range, if I can know, if if I already know the maximum length in the inner string, with that result of the sub problem, or I can say smaller problem or child problem, I can solve the given question, the original range, easily. Yeah, so I can utilize the result of this sub problem to solve the original problem. So that being said, yeah, so in that way I can use the recursion. That's definitely the recursion. And also, one more thing I can say about this question is that once I find the maximum length in, say, range 2 to 4, index 2 to 4, that answer result never changes, because in this question, the string I'm given is always the same. It never changes. So once I find the answer of the max length, I can just memorize it in the cache, and I can utilize that again and again. So in that way, I can avoid the unnecessary redundant operation. So that being said, I can use the recursion with the memorization. So definitely is the dynamic programming. Yeah. And that being said, let me think of the base case of this. Yeah. So let me think of the base case of this recursive function. So what I can say is that, firstly, at max, I will, remove 2 characters and I will solve the sub problem. So when removing 2 characters, I mean, I will think of the base case as length of the string is 1 or 2. If the length of the string is 3 or more, like ABA, even if you know, this, even if leftmost character and rightmost character are the same, in that case, the sub problem I solve is C only, because in case of ACA, A and A are, chosen. So in that case, yep, still there is some character remaining. But in case of the length of the character is 1 or 2, if I try to take 2 characters, there's no remaining character. So that I will take them as the base case. So I will think 3 cases. Number 1, the remaining character is only 1. In this case, the maximum length is 1, obviously. And if there are 2 characters remaining, the maximum palindrome subsequence should be length 2, which is AA. And if 2 characters and they're not the same character, it should be 1. Either of A or B is the longest. Both of A and B are the longest, palindromic subsequence. Okay, so there's the base cases in my recursion. So that being said, let me implement the method. Okay, so this is the, edge. Sorry. Now I've implemented, aside from the recursive function implementation. Basically, this max ranks is the recursive function. So the results should be cached. And after defining it in line 25, or I mean, in line 26, I call this function with the whole range, and I will return that answer. Yeah, so that's it. So that being said, so what I should do from here is implement the max ranks recursive function. First, I will implement the base cases. Yeah, so these are edge cases. And the next thing I will implement is if leftmost character and the rightmost characters are the same in that case. Yeah, this is it. I will choose leftmost and rightmost characters and then think of the inner ring. Otherwise, I have to skip leftmost character or rightmost character, or maybe both of them. Like this. Okay, so now I'm pretty sure of this implementation. So let me execute my code with me. Never submit. Oh, wrong answer. Oh, sorry. So my mistake is that in line 26, yeah, if two characters are not the same, it should return 1. So basically, in this question, because the length of the string is at least 1, the longest palindrome subsequence is at least length 1. So at least 1. Yeah. So it's impossible that the output is 0. So that's why I took a look at this base case. Oh, sorry, my screen was not shared. So let me, with me. Sorry, so since like my screen was not shared, so I demonstrate this again. So when I submit this code, yeah, this is accepted for the given two test cases, but for this case, the answer is wrong. And the problem is right in line 26. So this should be 1. So in the case there are two characters and they're not the same, like A, B, I should return 1, not 0. So when I fix it and I submit it, it's now accepted. Great. Okay, so that being said, let me implement, let me tell you about the complex analysis. So for time complexity, it should be n squared time. So I will think how many times this recursive function is called and without cache. I mean, the recursive function is called and cache is not ready. So there should be n squared, or I should say n times n minus 1, because it's exactly the number of combinations of left and right pointers. Boundaries. So it should be n squared. And inside of the recursive function, everything is done in the constant time aside from another function call. And another recursive function is call is counted in inside of the call side to the time compressed analysis. So I don't have to take care of it. This should be n squared time complexity. And for space complexity, it should be n squared too. The only data structure, which is not constant space, is only caching. For this cache, the key should be the tuple of left boundary and the right boundary, and the value should be integer lengths. So there should be, a n squared number of key value pairs. So the space complexity should be n squared. Yep, that's it. Okay, now I work on the second approach, bottom-up dynamic programming. So in my second approach, oh, wait a minute. Basically, I will use the DP table, 2D table. Okay. So in the case of this string, I will build the 2D table in this way. Yep. And let me tell you what this DB table signifies and represents. For example, for this cell, this position represents the substring B. This begins from B and ends with B. And for this position, it's BB. It begins with B and ends with B. And for example, this position, this begins with A. Oh no, this begins with B and ends with A. So it should be BBA. Yeah. So every character in the vertical line signifies the start character, and each character in the horizontal line represents the end character. Okay, that's it. So now I will think. Oh, and one more thing I try to tell you is that these cells I don't use because obviously they're embodied substring. Because for example, this begins from the second B but ends with the first B, which is not buried substring. I will just forget, yeah, these bottom left cells. Okay, and for each cell, I will fill in the maximum length of the palindromic subsequence. So for example, this B, this should be 1. And for this B, this should be 1. All of them should be 1 because they're single character. And for this here, this should be 2 because this represents BB and 2 characters are the same, so it should be 2. For this 2, but for here, it should be BA, 2 characters but they're not the same, so it should be 1. And then here, this should be AB, so this should be also 1. Actually, these are the base cases I talked about in the top-down approaches. From here, it becomes interesting. So for here, when I take a look at this represents BBB. And as I said before, the DP equation I can say is Um, if start is equal to end, it should be 2 plus max length of start plus 1 and minus 1. So this means that in this case, this start plus 1 and minus 1 position is represented as here. What should I say? Maybe I should say x. So this should be 2 plus x. And otherwise, I cannot choose 2 characters, start and end. And I said, I will think of 2 cases, skipping the first start character or skipping the end character. So when I skip the first character, that signifies the range here. Oh, wait a minute. Oh, sorry, here. So that's what I should take care. And also, I will think of the another case when I don't use the end character. So in this case, BB. So this is a string which starts from the same start but ends one character earlier. So it should be represented as this character. Yeah. So in this way, for the question mark position, I can fill this in like this way. Yeah. So I can keep doing with that. So for example, this case, b is equal to b. So I will take a look at 2 plus 1 here. So it should be 3. But, okay, so that's the basic idea how I can fill in the, cells. But one thing I have to take care is that the order of filling each cell matters. So for example, if I try to fill in this, because this one is not filled yet, so I still cannot fill this cell. So that being said, the order of the, to fill in the cell should be like this. So firstly, I will take a look diagonally from 0, 0. Then I do it here and then here. Sorry. So when I fill in the cells in this order, 1, 2, 3, 4, 5, 6, I can fill all of them because, left cell, bottom cell, left bottom cell, all of them, all of these adjacent cells are already filled in. Okay, so that being said, let me start the implementation. So this is a DB table I will fill in, and I have to visit each cell in this order. So let me say, okay, so firstly I will visit 0, 0. Then after that, I will increment start and end, each of them, until it's in the board. Next, I will start with start 0 and 1 and keep going this direction. Then I will start with start 0 and 2, and keep going. So firstly, I will set the end index first, and for each start with from 0. And while start and end is in the stereo in the range in the board, I will fill in, you know, this one, and then I will move the position in this way. Okay. Yep. And in the end, I will return the maximum value in the DP, or maybe I can do it in this way. So I will initialize the max strength with this, and every time I fill in the DP table, I will update max strength with that. Then I will return the max strength in the end. Okay. So now I implement line 81. So as I said, so I told about position X in line 66. So start should be one character later, but end is one character earlier. Yep. Otherwise, this or this. Okay. And as I said, I will update the max strength with the filled-in value. If it exceeds the current max strength in this way. Okay. Let me execute my code with this. Wait, I think I forgot to tell about the edge case. So as I said first, for this, I mean, in line 53 to 55 example, number 1 to 3 is only a single character, and I have to fill it all with 1. And then also number 4 to 5 to be 2 character ranks. So I should fill in these cells without, seeing adjacent cells. Yeah. So let me include that. So if these are two characters, it should be like this. This, corresponds to the base case in the top-down DP. Okay, now accept it, and I will submit it. Great, now it's accepted. So let me talk about the complex analysis. So for time complexity, it should be n squared because I have to fill in each cell in the DP. Accurately, it should be n squared out of 2, but in time bigger notation, it's n squared. For each cell, I use only constant time to fill in. And for space complexity, it should be also n squared. The data structure I will use is, which is not constant space, is DP table, which is 2D, n squared cells. This should be n squared. Okay, so that's about it. This question. Yep. So I I was thinking of the follow-up question for this. Like this. So this is a follow-up question I will solve, but I decided to, take another video for this follow-up question. Yeah. So I will finish this video with this for now. Let me quickly wrap up. So in this question, I mean, I'm giving a string S and my task was to find the longest ranks of the palindromic subsequence. And I introduced two approaches. The first one is top-down DP, and the second one is bottom-up DP. And for the top-down DP, I use the recursion with the memorization. And the base case is, the cases when length of the current range is length 1 or 2. And for bottom-up approach, dynamic programming approach, I use the 2D DP table n by n, and I filled each cell of them with the maximum length, which is represented by the each cell. And what I have to take care with that, the order to fill in the cells really matter. So I fill the cells in this order. Yeah. And also I had to take care that for the, cells which represent single character or two characters string, I have to fill them in as a kind of base case. So not from the adjacent cells, but from the cell itself. Okay, that's pretty much it. Okay, thank you so much. Bye.